Dear students, in this video lecture, you are going to learn the protection of transformer against high resistance ground faults. So far, we have studied the protection of transformer against the internal faults using percentage differential relay. The percentage differential relays that we have studied so far have a minimum pickup current. If the fault current is less than this minimum pickup current, then the fault remains undetected. Hence, the percentage differential relay cannot be used in detecting the fault which has got very high resistance, due to which the fault current is very low. The examples of such high resistance faults in transformer are the winding to core fault. These faults are of type phase to ground fault. The operation of sensitive relays used in detecting such high resistance faults must be restricted to the winding of the transformer, but not to the other ground faults in the system. Otherwise, such sensitive relays will keep operating for all the ground faults. Because of this reason, the relays used to detect high resistance ground faults are also called as restricted earth fault protection relays. Before we go into the study of high resistance ground faults on the transformer, we must know that zero sequence currents flow if there is an unbalanced fault in the system whose neutral is grounded. If unbalanced fault occurs on the system which is not grounded, then there will be no zero sequence currents. Flowing in the system. Now let us study high resistance ground fault on star side with relay placed on delta side of a transformer. Now let us consider a three-phase delta star connected transformer with neutral of star connected winding grounded. If a fault occurs on the star side between the phase and the ground, then the zero sequence currents will flow on the star side between the faulted phase and ground, but there will be no zero sequence currents on delta side. Therefore, the spill current through the relay will be equal to 0. Hence, the restricted earth fault protection relay will not operate. If there happens to be a fault on delta side between phase winding and the ground, then the zero sequence current will flow between the faulted phase and the neutral of the source through the ground. This results in the currents through secondaries of CTs. Hence, spill current through overcurrent relay, and the relay will operate. It means that the restricted earth fault relay operates only for the fault on delta side but not for fault on the star side. So, restricted earth fault relay shows stable operation. Now let us study the protection of a transformer against high resistance ground fault. The transformer being delta star connected and the neutral of star connected winding being grounded. Here you can see the restricted earth fault relay is on the star side. If phase 2 ground fault occurs between the CTs and the load, then the fault current will flow through the secondaries of the CTs. However, the current circulates through the CT in the neutral path and the CT in faulted phase. Thus, no spill current flows and the scheme remains stable on external fault. If a phase to ground fault occurs between the transformer and CTs, in that case, there will be no current flowing through the CTs connected to measure current in the lines, but the fault current flows through the neutral. Hence, the CT connected in the neutral measures the fault current. Hence, in this case, the spill current will not be equal to 0 and the relay operates. It means that the restricted earth fault relay operates only when there is a fault in the restricted zone, but not for the fault occurring outside the restricted zone.